Many people are fascinated by images showing a visible line where the Pacific Ocean and the Atlantic Ocean meet, but don't seem to mix. This natural phenomenon often sparks curiosity and myths about why these massive bodies of water remain separated. The truth, however, lies in the science of oceanography and the unique properties of ocean water. The science behind the unmixing of oceans. The Pacific and Atlantic Oceans do indeed meet and their waters mix, but the mixing is not always obvious to the naked eye. The appearance of separation is mainly due to differences in water properties and ocean dynamics. 1. Differences in water density. The water in the two oceans can have different densities due to variations in salinity, salt content. Some areas have saltier water, which is denser. Temperature. Warm water is less dense than cold water. When two bodies of water with different densities meet, they tend to form a boundary called a halocline for salinity differences, or thermocline for temperature differences. These boundaries slow down the mixing process, causing a visible separation. 2. Ocean currents and circulation. Ocean currents play a major role in how waters from different oceans interact. The currents that flow between the Pacific and Atlantic are complex, and the water masses tend to flow alongside each other rather than instantly blending. This creates distinct layers or boundaries where water types differ. 3. Chemical composition. The two oceans may also differ slightly in chemical makeup and suspended particles, which affect water color and clarity. This contrast can make the dividing line more visible. Real mixing happens just slowly. While the boundary looks like a clear division, over time, the waters do mix through processes such as turbulence caused by waves and tides. Wind-driven mixing. Deep ocean currents moving water vertically and horizontally. This mixing happens over large timescales and vast distances, which is why the separation appears dramatic in photos, but is not permanent. Conclusion. The Pacific and Atlantic Oceans do meet and their waters do mix, but differences in density, temperature, salinity, currents, and chemical composition cause temporary and visible separation. This natural phenomenon is a beautiful example of how dynamic and complex Earth's oceans are.